We are from Roy's Academy faculty team, and today we'll learn course CBSE Class 10, subject Mathematics, Chapter 1, Real Numbers, topic Proving the Irrationality of Numbers. For obtaining similar video explainers, please connect Roy's Academy at 8910-890311. Repeating the number again, 8910-890311. Or another number, 8910-600503. Repeating the number again, 8910-600503.
You know, we all kind of feel that a number like the square root of 2 can't be a simple fraction, right? But how do you actually prove it, like with 100% certainty? Well, it turns out it takes a really clever bit of logic, and that's exactly what we're going to unpack today. We're diving deep into real numbers to see how we can prove a number is irrational.
All right, so here's the game plan. We'll start with a super quick recap. What even are irrational numbers? Then I'll show you the one key theorem that's basically our secret weapon for all of this. After that, we hit the main event, a step-by-step walkthrough of the famous proof for the square root of 2. And once you see that, you'll see how we can use the same exact idea for other numbers. And of course, we'll wrap it all up with the key takeaways.
All right, let's kick things off with a quick refresher. What exactly are we dealing with when we talk about irrational numbers?
Okay, so what in the world is an irrational number? You know, it's actually pretty simple. It's just any number that you can't write down as a nice, neat fraction. Rational numbers, they play by the rules, right? Like 0.5 is just 1 over 2. Easy. But irrational numbers, they're kind of the rebels of the number world. They refuse to be written down as one whole number divided by another.
And I bet you already know some of the most famous ones. We're talking about numbers like the square root of 2, the square root of 3, the square root of 5. Those are the classics. And then, of course, you've got the superstar of them all, pi. Oh, and don't forget those weird-looking decimals that just go on and on forever without ever repeating? Yeah, those are irrational too.
Okay, so here's the thing. You can't just look at a number and know for sure it's irrational. We need something more solid. We need a tool, a powerful rule that lets us build a rock-solid case. And that brings us to the key theorem. Really, this is the most important tool in our toolbox today.
So here it is, Theorem 1.2. And honestly, it sounds more complicated than it is. It just says this: if you have a prime number, let's call it p, and that prime number can divide another number squared, you know, a squared, then it has to be able to divide the original number a as well. I know, it might seem a little abstract right now, but trust me, this simple little rule is the absolute cornerstone for the entire proof we're about to walk through.
Let's make that way simpler. Think about the prime number 2. All this theorem is saying is that if a number squared is even, meaning it's divisible by 2, then the original number, before you squared it, had to be even 2. It just makes sense, right? Like take 36. That's divisible by 2. And its square root, 6, also divisible by 2. The logic is totally sound, and it's the key that's going to unlock this whole thing for us.
All right, time for the main event. We are going to prove once and for all that the square root of 2 is irrational. And to do it, we're going to use this super cool, super powerful technique called proof by contradiction. Seriously, think of it like we're detectives trying to crack a case.
So how do you even prove that something is impossible? It's a tricky question, isn't it? I mean, you can't just test every single fraction in the entire universe to see if it equals the square root of 2. That would take, well, forever. And that's exactly why this method is so clever.
The whole strategy is to flip things on their head. We're going to start by assuming the exact opposite of what we're trying to prove. So let's just pretend for a minute that the square root of 2 is rational. We'll take that idea, follow the logic wherever it leads, and see what happens. The goal? To see if we walk ourselves right into a corner, a logical dead end. That's the contradiction we're looking for. Okay, you ready? Let's walk through this together step by step. First, our big assumption. We're going to assume the contrary, that the square root of 2 is rational. So if it's rational, what does that mean? It means we can write it as a fraction, a over b. And this is the most important part. We're going to say this fraction is in its simplest form. That means a and b have no common factors. They're co-prime. You know, like 3 over 5, not 6 over 10. Okay, next, a little bit of algebra. We just square both sides. That gives us 2 equals a squared over b squared. Rearrange it a little, and you get 2b squared equals a squared. Now, let's look closely at a.
If a squared equals 2 times something, that means a squared has to be an even number, right? And what did our key theorem tell us? If a squared is divisible by 2, then a itself must also be divisible by 2. Got it? So now watch this. This is the cool part. If a is divisible by 2, we can just write it as 2c for some integer c. Let's plug that back into our equation. We get 2b squared equals, instead of a squared, 2c squared. That simplifies down to b squared equals 2c squared. And wait a second, that means b squared is also divisible by 2, which means b has to be divisible by 2 as well. And boom, there it is. That's our contradiction. We just proved that a is divisible by 2 and that b is divisible by 2. But hang on, our whole starting point was that they had no common factors. We've just contradicted ourselves.
See, we've hit a wall, a complete logical impossibility. The only way we could end up in a spot where a and b both do and do not have a common factor is if our very first assumption was totally wrong. That whole idea that the square root of 2 is rational, it has to be false. And if that's false, the only other option is that it's true. So, the square root of 2 must be irrational. It's such a neat piece of logic, isn't it?
And here's the best part. This whole proof by contradiction thing, it's not just the one-trick pony for the square root of 2. Nope. We can use this exact same blueprint to tackle all sorts of other numbers. Let me show you what I mean.
So what if you wanted to prove that the square root of 3 is irrational? Well, you do the exact same thing we just did. Seriously, just go back through the proof and replace every 2 with a 3. And for the square root of 5, same deal, just use a 5. It works for the square root of any prime number. The logic is identical and just as solid.
Okay, but what about something a little different, like 5 minus the square root of 3? Is that irrational? Well, this proof is actually even easier. Check it out. First, we do our usual trick. Assume it's rational, which means it equals some fraction a over b. Second, just do a little algebra to get the square root of 3 all by itself. And stop right there. Look at what we have. On the right side, we've got a rational number. But on the left side, we have the square root of 3, which we already know is irrational. And there's just no way. You can't have an irrational number be equal to a rational number. It's impossible. So our assumption was wrong. And 5 minus the square root of 3 has to be irrational.
And there you go. We've totally cracked the code on how to prove a number is irrational. So let's do a quick recap of the most important things we've covered.
So what did we learn today? Well, for starters, we've got a crystal clear definition of what an irrational number is. We also have that crucial theorem under our belts, the one about prime numbers and squares. And the big one, you now know how to use that powerful method, proof by contradiction. You've seen how it works for the square root of 2, and you know how you can apply that exact same thinking to prove all sorts of other numbers are irrational too.
This was an initiative from Roy's Academy faculty team, and today we've learned on course CBSE Class 10, Subject Mathematics, Chapter 1, Real Numbers, Topic, Proving the Irrationality of Numbers. For obtaining similar video explainers, please connect Roy's Academy at 8910-890311. Repeating the number again, 8910-890311. Our another number, 8910-600-503. Repeating the number again, 8910-600-503.